for the Blended Algebra 2 class, we're in Unit 3, which is solving quadratics, and today we're going to talk about graphing to solve. But before we do graphing to solve, I just want to review the zero product law. That was in lesson 1 really quick. Remember, the zero product law says that if you're multiplying two things together, two numbers, two factors, and the two things you're multiplying equals 0, then one or both of those things that you multiply has to equal 0. And we use the zero product law here when we are solving quadratics by factoring. Because when we have two factors, like in example A, or in example 1A, when you have two factors, in between these two factors, they're being multiplied. And we want to know where the x-intercepts are, and that's where y equals 0, which is why we set the equation equal to 0. In order to find where the equation is equal to 0, we have to then take each factor here, make a mini equation set equal to 0, and solve for x. When we solve for x, that will give us the value of the x-intercept, or the solution, or the root, whatever you want to call it here. So in this first one, I add 7 to both sides, and then I get one solution is that x equals 7. On the other one, if I subtract 2, I get a second solution is that x equals negative 2. All right, A was already factored for us. If I look at B, B is not factored. I have 6x squared minus 150, and I want to think about always that I have to look for a GCF, a greatest common factor, first when I factor. Here, there is a GCF. There's a GCF of 6. So I'm going to factor a 6 out in front, and inside those parentheses, you're left with x squared minus 25. Now, I have to look at the x squared minus 25. That does factor again. There's two terms. There's a minus sign in the middle, and that well, I can take the square root of both terms, which means I can use the difference of squares. So I take the square root of each term. The square root of x squared is x. The square root of 25 is 5. And I use those to help me factor. Now my GCF comes down. It just hangs out in front. And from the difference of squares here, I will have an x on the left in both parentheses, a 5 on the right, a plus and a minus. All right, now I have 6 times x plus 5 times x minus 5, all equal to 0. And remember that zero product law says that I have to set each factor equal to 0. Well, the only factors I truly have to set equal to 0 are those within x. I'm not going to set the 6 equal to 0 because 6 equals 0 is a false statement. That's not true. I ignore it if I just have a numerical GCF. So now I take x plus 5, set it equal to 0, x minus 5 equal to 0, and solve for x. So I subtract 5, and I get one solution, or x-intercept, is at negative 5. And over here, when I add 5, I get that x equals positive 5 as another solution. So this quadratic had negative 5 and positive 5 as its solutions. Last one here, and then we'll jump to solve by graphing. 4x squared equals negative 16x minus 7. When I factor, or solve by factoring, I must have my whole equation set equal to 0. So what I'm going to do is I'm going to move what's on the right-hand side to the left-hand side. All right, when I do that, it's going to cancel out what's on the right and have it set equal to 0. So I will have 4x squared plus 16x plus 7 equals 0. Now there is no GCF between 4, 16, and 7, so I'm going to factor. And the factoring method I'm going to use is split the middle because I have 3 terms. To split the middle, remember you multiply the first and the last term, which is 28. And you need to find all the numbers that multiply to 28 because our goal is to find them that add to 16. Positive 28 to multiply, positive 16, I'm looking for 2 positive numbers. So my factors of 28 are 1 and 28, 2 and 14, 4 and 7. Looks like 2 and 14 are going to work for us. So when I split the middle, the 4x squared comes down, the plus 7 comes down. In the middle, I split this 16x up with plus 2x plus 14x. Now from there, what I'm going to do is grouping. So I put the first two terms in a group, the last two terms in a group. And from each group, you look for a GCF. From the group on the left, it looks like 2x is the greatest common factor. So I pull a 2x in front. And when I divide here, 4 divided by 2 is 2x. And here, 2x divided by 2x, anything divided by itself is 1. On the other parenthesis, 14 and 7 have a 7 in common. So I pull a positive 7 out, and you're left with 2x plus 1, which is a good thing because these two terms are the same. To write your final factored form, you take what's in the parentheses that are the same, 2x plus 1. That's going to be 1 factor. And the GCFs out in front are the other factor. Now, I have my factored form. Again, we're using the zero product law to solve. So I take each factor and set it equal to 0. Now I'm going to solve for x. I'm going to start by subtracting 1. So I'll have 2x equals negative 1 and divide by 2. So I get that one solution is at negative 1/2. Same process on the other side. I subtract 7 to start and then divide by 2. So I will have that my other solution is at negative 7 over 2, or negative 3/2. All right, so you should feel fairly comfortable at this point with solving by factoring. If not, you need to go back to the factoring extra practice that is within the module in lesson 1 and do some of that. But let's move on to graphing. For this lesson, you are going to be using the online graphing tool called Desmos. We will talk about that in a few minutes. But you'll want to go to desmos.com. In another tab on your computer so that you can follow along and practice using Desmos. So what we have here, it says some fill in the blanks. The values of x that solve a quadratic function are called solutions, as we reviewed with solving by factoring. Now, these solutions are also called roots or zeros because when we plug the solution back into the equation, so when we plug that whatever x equals back into the equation, it causes that equation to equal 0. But we want to talk about today what happens when we graph these quadratic functions. So let's start here with example 2. It says factor to solve this quadratic. We have x squared minus 2x minus 3. 3 terms, no GCF. We're going to factor by using split the middle. We're going to have a 1 in front. 1 times negative 3 is negative 3. I need to add to negative 2. So my options are 1 and negative 3 or negative 1 and positive 3. It looks like 1 and negative 3 gives us negative 2 when we add. So to factor here, I will have x squared plus 1x minus 3x minus 3. And I'm going to group. From the first group, I can pull out an x, and I'll be left with x plus 1 inside. And because this term is negative, I'm going to pull out a negative here and have x plus 1. So when I write my final factored form, I'll have x plus 1 times x minus 3. And if I'm solving that by factoring, again, I would use the zero product law just like above. I would set each factor equal to 0. When I subtract 1 on the first side, I get that I have x equals negative 1 as a solution. And on this one, I would have x equals positive 3 because I added 3 to the other side. I know I did that one quickly, but you should be able to factor by solving on your own as well. Now, that's factor to solve. Let's see what happens when we graph. So it says using Desmos.com, let's make this graph on here. So when we go to Desmos, in the first box here, you are going to type in the equation. So I'm going to click on the keyboard, and I'm going to type in x squared minus 2x minus 3. And you should see on the picture over here that you can see a parabola. Now what I want you to do is click right on the x-intercepts. You should get 2 points. Now we're going to make a connection here in a second, but we should notice that these x-intercepts, -1 and 3, those are the same as the solutions we got right here. So let's fill that into the box really quick. Between the graph and its solutions, the solutions are the x-intercepts of the graph. And we saw that previously in factoring to solve. Okay, now we want to make the graph. So on Desmos, you can make a table because we need to know what points to plot in order to graph this function. To make a table, you hit the gear and then the button that looks like a table. And we are able, here we go, to see some points. I would plot at least -2 to 2. You should click in here. I would probably also plot a few more. So like 3 and 4. You can fill in points on the table. Our goal is to plot as many points as possible. Let's see what 5 is. 12. Yeah, 5 won't fit. So you need to plot, I would say, from -2 to 4. So I want you to hit pause. Here's the table of the points, and you should get a parabola that looks just like this. Okay, so hit pause on the video. All right, now when you come back, you should see I went over to the graph, and I plotted all the points that were on the table in Desmos. You should have a parabola that looks the same. Again, notice that the x-intercepts here are at -1 and 3. That's where what the x-intercepts we found by factoring. All right, on the back of our paper, let's practice with just using Desmos here. So remember, it says the x locations on any function where the output is equal to 0 is also known as the 0 of the function. That's the same as the x-intercept. So let's graph this new function, x² plus 5x plus 3. So when we go back to Desmos, you can exit out and retype your new function, x² plus 5x plus 3. Here's our new graph. Now, when I click on these, those are not whole number x-intercepts, okay? So we need to figure out where do my x-intercepts go? So I'm going to change the settings on the window here really quick. Okay, it's a little easier to answer that next question now. I just changed the window setting. So the question is asking us, between which x values do the zeros of the function fall? So it looks like these zeros, oh no, the wrong thing. The left one falls between -5 and -4. So we're going to say that. -5 and -4. And then the other x value looks like it falls between -1 and 0. Now let's take a second again, and we're going to plot this graph on our paper here. I want you to go back to Desmos. We're going to make a table. So we hit the gear and the table button. And I want you again to plot as many points as you can. So it looks like here, 217 isn't going to work. But I could plot, let's try -3. Oh, that's +3. -3 will work. Let's see what -4 is. -4 looks good. So it's a little out of order. -5. Let's see what -6 is. -6. So let's do this. I want you to plot -6 to 1. Okay? So I can do it with you. So I'm -6, 9. So -6, 9 here. Then I go back to Desmos, -5, 3. -4, -1, so I'm on this point right here. -3, -3. All right, we're getting there. And then I jump up to the top now. -2, -3. And it looks like I should be able to then, I'm going back up, so I'll be symmetric here. All right, so this parabola looks something like this. So the only thing about Desmos is you do have to sometimes add points to your table so you can plot as many as possible. Now let's see if we can solve this by factoring. So let's look. I would need you to split the middle. Need two numbers that multiply to 3 and add to 5. The only factors of 3 are 1 and 3, and those add up to 4. So it looks like that quadratic is prime, and I cannot solve by factoring. So the only way we can solve this quadratic is by using Desmos to approximate our zeros. And that's really easy because when I come to Desmos, all I have to do is click on the x-intercepts, and it will tell me where the x-intercepts are. You know they're x-intercepts because the y is 0. All right, so let's put those on our paper. We will have one x-intercept is at negative 4.303, which is between negative 4 and 5, like we said. And the other one is at negative 0.697, which is also between negative 1 and 0. All right, so we have just a couple more. We're just going to keep practicing with Desmos here. Our big idea of the day is that graphing functions is easy to find the zero roots and x-intercepts, especially when you cannot factor. So for now, if we can't factor a quadratic, we can use a graph. Then we'll learn more methods. All right, so we're on to example 4. Okay, so for this example, it's asked what are the roots of the quadratic. So we're going to start by graphing y equals negative 3x squared minus 14x plus 5 in Desmos. Okay, so we're going to go to Desmos here, and so y equals negative 3x squared minus 14x plus 5. Okay, so there's our graph, and when I look at this graph, again, it's really easy to find the x-intercepts because you just click on the axis and it gives it to you. So the left x-intercept's at negative 5. So we'll write that one down. Where are we at here? Here we go. X equals negative 5, and then it says round up nearest thousandth. So this one will be at 0.333, and that looks like it's going to be repeating. Now for this problem, it's really important to recognize that 0.3 repeating is the same as the fraction 1/3. Now, it says in part B, it says based on the nature of these roots, is this quadratic factorable? Well, the nature of the roots mean, is this rational? Are the roots rational, or are they irrational? 5 and 1/3 are rational numbers. Now, when I have rational numbers, that means that my quadratic is factorable. Okay, and let's see why that's the case. So in this problem, I would start by splitting the middle. Negative 3 times 5 is negative 15. Two numbers that multiply to negative 15, we need a positive and a negative. So 1 and negative 15, 3 and negative 5. And then I would go the other way. So I'd have negative 1, positive 15, negative 3, 5. Well, the numbers that add to negative 14 here are going to be 1 and negative 15. So when I factor by splitting the middle, I would rewrite the first term, and I would do plus 1x minus 15x plus 5. I now go into the method of grouping, so the first two and the last two terms. My first group, I'm just going to pull out an x. Actually, I'm going to pull out, this one's tricky. I'm going to pull out a negative x. I know we don't typically do that. I'm not going to ask you to do that on a test or anything. But for the notes, I'm going to pull out a negative x in front. So I am left with positive 3x here. Positive divided by a negative is a negative 1 because the x's cancel. In here, because this term is negative, I also pull out a negative GCF. So I'll pull out a negative 5, which will leave me with positive 3x minus 1. My factored form is negative x minus 5 times 3x minus 1. And if I was solving this by factoring, I would take each factor and set it equal to 0. So the right one here, if I added 1 and then divided by 3, I get 1/3, which is one of the roots. On this side, if I add 5, and then I have to divide by -1, 5 divided by -1 is -5, which is the other root. So it is factorable. You don't have to factor every time it is factorable, but we need to be able to tell if it is factorable or not based on whether the roots are rational or irrational. So let's try a couple more. We're going to solve 3x squared plus 3x minus 4 by graphing. Okay, so new problem, y equals, start this time with positive 3x squared plus 3x minus 4. Oops. These roots, I get 1.758 and negative 1.758 and 0.758. Okay, so negative 1.758 and 0.758. Those two roots are irrational. Since they are irrational roots, we suspect that we cannot factor. But let's try just in case. I would need two numbers that multiply to -12 and add to 3. So let's look at our list. 1 and -12, 2 and -6, 3 and -4, -1 and 12, -2 and 6, -3 and 4. So do I have a pair of numbers that add to 3? Well, these add to -11, -4, -1, 11, 4, and 1. It doesn't look like any of them add to 3. That's why it's not factorable. That quadratic would be prime. All right, the next one, let's graph this, -2x squared minus 8x. So y equals -2x squared minus 8x. When I look at this, I have roots at -4 and 0. Well, those two roots, -4 and 0, are rational numbers. So yes, this quadratic is factorable. Okay? I'm not going to do the whole thing, but if I have two terms here, this one's actually factorable by GCF. I can pull a -2x out in front, and I'd be left with x plus 4. That is factored form, and then you could solve and get the same root. All right, last one on our notes here. -x squared plus 6x plus 2. So we'll start one more time. Y equals -x squared plus 6x plus 2. When I look at this graph, these are my roots, -0.317 and 6.317. Those look like those are irrational roots, right? -0.317 and 6.317. Those are not rational numbers, so this is not factorable. All right, there's some practice I'd like you to do it. It's pretty quick on graphing, solving by graphing. You can check your answers on the Key on Canvas or watch the video.